Composite construction is a type of construction method that has been utilized in South Africa for quite a while now. Let's say maybe 3 or 4 decades at least, maybe even longer. But let me just go back to the basics and try to explain what we're discussing here. Because when a lot of people hear the word composite, what they think of are things like fiber reinforced resin systems, like for instance, composite tanks. Or some of you may have heard of a Boeing 787 Dreamliner plane, which has a composite fuselage. These are essentially plastic structures that are somehow reinforced either by glass fiber or carbon fiber or some other fiber. This is what is typically used in the regular nomenclature when you say composite. That's not what we're talking about here. What we are referring to here is a composite behavior, and that basically means two materials that are different working together structurally. And in this case, it's actually steel, structural steel, and concrete. Now, you may then say, well, how about reinforced concrete? The standard stuff that we use all over the place. That is indeed a composite material. Composite construction is essentially this combination of large structural steel members. These could be I-shapes, tubes, and such, with concrete that sits around them, inside or above them. And they can be used in different types of structures. And this is in fact now, I would say, exploding into a very popular type of construction method all over the world. And maybe I'll talk a little bit more about why as we're discussing.
So, Emmanuel, what types of structures are you typically seeing composite construction in?
Okay, so the types of structures that I was discussing earlier in South Africa are typically building construction type projects. So that basically means multi-story type projects. It could be office buildings, it could be residential. So for instance, we have some pretty large composite buildings in CBD in Joburg from the late 80s and early 90s. These are essentially steel frame buildings that make use of concrete slabs that act in composite with the steel members. In some cases, I've also seen composite construction in some industrial applications, in mezzanines, in industrial plants. So this is not a new method of construction in South Africa when it comes to buildings and things like mezzanines. However, if you go outside of South Africa, you see the application of composite construction in many other types of structures. For instance, you see it in use in bridges, very popular in the US, in UK, in Europe. Sorry, I have to distinguish because the UK is no longer part of Europe. Now, of course, in the Middle East, it's huge in the Gulf, China, and quite a bit also in places like India. So, and I've been surprised to see composite bridges being used in many other parts of Africa where they couldn't get huge construction materials into site. So they've essentially been able to move these modular type of construction methods into these places that surprised me, rural places. The other area where you'll see composite construction, which is at the frontier, let's call it, of construction now, is things like nuclear power plants. So countries like South Korea have put in a huge amount of development work behind modular construction of nuclear power plants, and almost all of those are composite in a different way, which is essentially between plates, where you fill concrete between plates. So this method of construction has become very popular in many different areas and in different geographies. So it's quite exciting, and there's a lot of research going on in composite construction all over the world now.
So, Emmanuel, not a question that I had originally had in my kind of bank of questions I wanted to ask, but what are some of the kind of landmark projects that stand out for you in terms of composite construction, either on the continent or in Europe or in the Gulf, that have happened in the last couple of years that are really, kind of piqued your interest?
Yeah, so the iconic ones obviously are these tall buildings in New York that have been constructed in the last few years. Many of them essentially very residential, expensive properties. Whenever you hear some new rich person has just bought a flat, in New York, it's typically a construction that makes use of composite construction. But I would say the ones that have really piqued my interest have been used in these nuclear power plants that are typically contracted by large South Korean contractors, because they've been able to build nuclear power plants at a much faster pace than what we're traditionally used to. In other cases, bridges are very exciting. You'll see in Germany, and now recently, there may have been one or two also that were done in South Africa, even though they were not vehicular, they were pedestrian. And that was, again, exciting because the speed at which the bridges were put up was incredible. Essentially, what you're talking about is you don't close the road underneath. You essentially launch these bridges overnight. And there's no risk really associated with putting up a bridge anymore. If you compare it to, for instance, what we saw on the M1 before, where there was a concrete building, that bridge that was planned, and the formwork collapsed. I don't know if you remember this from a few years ago. So all of these types of risks are gone. So I would say the notable things that I've seen are in all three areas: in buildings, bridges, and nuclear power plants. I've always wondered here why the mining industry hasn't picked up on this, especially in construction of headgears, because it sounds like a very viable approach. And I've raised this with some of these larger mining houses, but it's a very conservative industry, and they do make use of just technologies that they've used before. So this is yet another area to explore maybe for our mining industry here, because there are many advantages that are not necessarily visible to the mining industry yet with composite construction.
So in terms of advantages of composite construction, what kind of stands out for you, Emmanuel? What is the benefit?
Yeah, so I would say that the big distinction between doing composite construction and your traditional construction is the fact that the design and construction are essentially united in this sense. It's not distinct. So the way we do traditional buildings and bridges is an engineer sits in an office and plans the thing along with an architect. They do drawings to show what type of concrete structure or rebar, detailing, whatever has to be done. And then it gets passed on to a contractor, and the contractor has to go and figure out how to actually build that thing. So what that means is, for instance, if you're doing a building, the contractor now has to go and source all the formwork, all the props, all the stabilizing elements, supply, all the water that's required, let's say, energy, and that is not part of the design. The design very rarely includes all of that information. That's left up to the contractor. With composite construction, that's actually not the case, because the construction method itself is designed into the structure. What I mean by that is typically what you're doing with composite construction is you're making use of permanent formwork. What that means is the formwork that you use for construction itself is part of the structure in the end. So, of course, the advantages are huge. And when I say huge, I mean not only in terms of time savings, but the fact that now both the contractor and engineer are in full control of the full process of producing that building. Now, for instance, one simple example I can give you is, because you don't have temporary formwork, there's nothing to haul in and out of sight. There's very little debris that you have to move out of sight. In terms of green and sustainability, this is huge. Moreover, your usage of things like water, for instance, are significantly reduced because you don't have to wash formwork, you don't have to go and clean up stuff, you're not mixing concrete on site. All of these things go away because you essentially have the formwork. You can come, bring a concrete mix truck and pour the concrete in that formwork, and that is the structure. That is the final structure. So, of course, if you're doing remote work, that is a huge advantage because of the logistics involved. But even when you're doing urban projects, the amount of savings in terms of energy, fuel, carbon, that all relates to carbon pollution, obviously, water resources, these are all emerging issues, is incredible. So I would say the most important aspect or advantage of this type of construction method, why it's becoming so popular around the world, is because it integrates design and construction in one. And this whole fragmentation that we see in our industry is resolved in that way, because a lot of issues that come up are related to this fragmentation, such as these collapses we were discussing, or quality issues that we're seeing, in even collapses that occur. For instance, recently Joburg Gen had a slab collapse from a small fire. Now, no one knows why that slab collapsed. The designer probably the design was right. The contractor probably believes the construction was done right, but clearly one or the other is off. So these types of problems go away because it's one integrated process that you would use. So this is what I would say is the main advantage of composite construction.
So you've touched a little bit on typical quality issues related to composite construction, but is there anything else that kind of stands out?
Well, yeah, I mean, quality is, I would say, by far the most important topic in construction these days. And it's not just quality of construction, it's also quality of design drawings. I just gave a talk, I don't know when it was, I think maybe almost a month ago now, to an event that was held by the city of Cape Town. So the city has become quite active trying to engage industry in trying to train their project management and engineering staff on, let's call it advances in construction. And the topic that was assigned to me was relating to quality. So they have a huge problem when they try to deliver projects. This is now the city of Cape Town, relating to both quality of drawings and also how to make sure that the quality of construction is on site is good. Now, what this brings up is, of course, the issue of complexity of what you're doing on site. So if you're doing very complicated work on site, the chances of you having a quality problem on site is very high, just because you've complicated the work on site. So what we're doing with composite construction is you're doing a lot of the work inside a controlled environment in a factory. You know, that's how steel beams are produced. That's how decking is produced. That's how many aspects of these composite construction elements are produced. And then when you get on site, you're doing very simple work, such as pouring concrete, maybe putting in mesh for temperature and shrinkage, let's say in the case of composite construction buildings. So there's a huge advantage in terms of reducing the chances for quality problems simply by the method of construction that you use. And so in that sense, this is actually a very good method. Now, it doesn't mean you don't do quality control. So for instance, if you're putting up a building, just to describe that, typically you'd put up, let's say, steel columns. Sometimes it might also be concrete columns or tubes. And then you put in your steel frames and you put in decking on top. Once you put that decking on, now it's ready for a pour. Now, before you do the pour, that decking and the steel has to be attached using shear studs. These shear studs are what make the concrete and the steel behave together. Now, those shear studs have to be welded on properly. So there is a quality control check that one has to do, but it is significantly simpler than the type of construction quality control that you have to do, let's say when you're doing your standard concrete pour on formwork. For instance, I mentioned the issue of the bridge on M1. The main issue there was nobody did the quality control of the formwork. Forget the final product. The formwork itself requires an engineer to go and review that the formwork is put up right, which is just the means of construction. It's not even the final product. So there is so much work that you need to do that are reduced when you make use of composite construction. That I say that composite construction, in actual fact, it implies much less risk, which is also associated with, of course, costs. So not only are you saving time, but you're also reducing your project risks by using these methods of construction. So that's in short, sort of what I would say about quality.
So just a reminder to all of our participants, if you've got any questions, you can pop them in the chat, or if you're comfortable putting your video on, you can ask your question in person, so to say, in person, as we're all working nice and remotely here. So Amanuel, how does composite construction compare in terms of costs with other construction materials?
Okay, so that's a very interesting question, because costs are one of these items. I don't know if there are QSs here with us, but QS will give you a number, right? So when you start your project, let's not even do a very complicated project. So if you want to put up a floor above your garage or something, you're going to get a number from someone about how much it's going to cost you. Now, of course, if there's anyone here who has ever been able to complete their garage project at the cost that you got from your QS, I would love to hear how that was done, because typically these numbers actually don't really mean anything. In fact, it's very difficult to know how much it actually costs you to finish these projects, because there's time delays that you don't account for. There's all the gray hair that you've essentially got from the project that you don't account for. There's all the divorces. There's all the quality problems that you have at the end that you don't account for. So the actual costs of projects are significantly larger than what you get to hear from the QS at the beginning of the project. This is true on a very small project in your garage, and it's also true on the largest projects, as we know with Kusile and Medupi, right? So we started off with a 50 billion Rand project for each power plant. We've already spent about 180 billion each, right? So these numbers that you get at the beginning are never really correct. So what we try to do here at the Institute, for instance, is to actually try to estimate what is the actual real cost of these construction projects at the end, and who actually knows. Now, one way to know is for the owner to tell you exactly how many rands and cents they've spent at the end, right? This is one clear way to know. You don't need any professional to do this. You just need an owner with a bank account, right? This is very good, a good start. It doesn't account for all the headaches and heartaches, but it actually accounts for the rands and cents that were spent. Now, when we do that, what we have found is, of course, if you use methods of construction that are faster and require less complexity on site, you typically end up with a significantly lower cost project than when you do construction methods that appear less expensive at the beginning, but take significantly more time, are vulnerable to delays, and have a huge amount of quality problems at the end. So we did a huge study at Stellenbosch on this matter to try to see, well, let's compare different construction methods. And what was interesting was we found that even using the standard construction methods and assuming nothing goes wrong on projects, that the composite steel construction methods came out quite competitive in South Africa, which was actually a surprise because people always assume that composite construction comes at a premium and are scared of using it unless there's a crisis and it has to be used. So I would say, without getting into the details of the study, that we were also pleasantly surprised. And for that reason, of course, many developers are making use of this method, and I'm talking about developers for housing, for office buildings and such, because they've understood. But these are owners typically. So that we see a big distinction between how owners make decisions and how the professionals who advise owners make decisions, because the professionals themselves don't seem to be aware of the actual costs of the projects because it's so fragmented. You know, an architect and an engineer are so involved with the specifics of the project that they can't actually be able to anticipate the construction costs. The contractor, of course, has their own interest, and so they may or may not reveal the actual costs involved in construction to an owner. The QS would be the person who should be closest, but the QS is also somewhat locked out of many. This is what came out of the discussion, for instance, with the city of Cape Town, is that many QSs are not necessarily technically trained enough to know what the risks are that are coming up. So very basic things were coming up, like, for instance, galvanizing, right? So if you need steel that's galvanized in Cape Town, how do you know how it should be galvanized? For a QS, that's a very difficult question to answer. They're just going to accept whatever some technical person gives them. But of course, once the structure has been put up for 2 or 3 years and the costs start adding up, which is what the city of Cape Town deals with, that QS doesn't have that in their account, that cost that comes up from the quality issues that they missed, right? So all this to say that it is actually a competitive method of construction. And I would advise, especially engineers, to actually get involved in the costing side instead of waiting for a QS to cost these projects, because there's a lot of secrets here to look out for.
So, Emmanuel, just a question from Jean-Pierre, just asking about, is composite construction currently addressed in legislation? Like, what is the kind of prevailing legislation around composite construction?
Yes, so let's discuss it in different parts. So the design of composite construction, meaning that what engineers typically do, which is the initial design and planning, is addressed in many parts of the SAISC standards. So for example, SAISC 10162-1 has various clauses and chapters in it for how you actually design composite structures. And of course, that's one of the documents that's recognized, or what's called deemed to satisfy SANS 10400. So in that sense, yes, it is part and parcel of our building regulations here, and has been used and in our standards for a long time. So this is not necessarily new. There are other aspects that one has to account for. So for instance, steel structures in general, just like concrete structures and other structures, have to address risks of fire, which I just brought up with Joburg Gen recently. Now that's 10400 also, meaning building regulations, but how do you actually implement fire protection of concrete and steel? Itself has its own standards, and that is also part of our regulations, which is pretty well understood. Now, just because you raise the issue of costs, a lot of people get nervous about, let's say, how do you do fire protection of composite structures? And what I have found, again, in my own practice, and also in the study that we did, is that a lot of money gets spent on fire protection in South Africa unduly. What I mean by unduly is I don't mean there's fraud or anything. There may very well be fraud, but that's not what I'm referring to here. What I'm referring to here is that it is not planned as part of the design. And what that does, of course, is the engineer simply designs the structure, doesn't think much about the fire protection. The architect or the QS goes and specifies the fire protection. And of course, this is done at the end of sort of, let's call it the design phase. And by the time the thing is getting built, of course, everyone is going to be overpaying, which is completely upside down to how it should be done. The fire design is part and parcel of the engineering design, because the member design in composite construction is directly driven by the requirement for fire protection. It's just like live loads and dead loads. So the fact that the engineer is not involved in it, in that fire protection, is why we have this very skewed and unrealistic costing of fire protection in this country. So on average, I would say people are paying at least double or 3 times the price that is available in this country if a structure is designed correctly. And we address this in the course that I give on composite construction, quite in depth. There are a few people here with us today who have taken these composite construction courses with me. I also address it at the course that I give at WITS for the postgraduate program. So this is an issue that is lacking, let's say. And this is what I meant about when the QS is doing the costing. This is exactly the problem, because the QS is not technically savvy enough to know why the owner is spending so much money. So in a sense, I would say the costing is something that has to be addressed by the engineers and architects to a much larger degree than is being done right now. Right now, it's being left up to QS essentially to cost, which I don't think is possible when a technology is new. Maybe a QS is quite good at costing traditional and old technologies, but not when something is new. So there's a breakdown in the market, in a sense, which is why there's this impression that the construction method is actually comes at a price premium.
Yeah. So if I can play devil's advocate a little bit here, Emmanuel, I know that we've got our red book and it does handle composite construction, but what if someone feels that it's a little bit one-dimensional or perhaps outdated? How do we supplement that as the Steel Institute? And you have mentioned your composite design course, which I'm just going to pop the link in the chat here. There is one coming up in August, if you want to check that out. How do we cover that?
All right, so I would say we've done quite a bit of work to try to address this issue. I myself have been involved in a project where we've actually written software that does something similar to the Red Book. It was done outside of the Steel Institute, but it does much more. And primarily the problem was that the structural engineering software tools that were produced that are being used in South Africa, such as Procon, did not have composite construction as part of their tools. Now they may have it now, but not at that time. So we've written a program that does this, and anyone who's interested can contact me about it, and I can tell you where to get it. So it's like the Red Book, but it does a bit more. So it checks things like vibrations and other issues that have to be checked when doing these very efficient structural systems. We're also addressing things like fire and stuff. The other thing that I would advise, and it's good that guys like Kennedy are here, is people must also look at the technologies that are available in the market now. So everyone is still stuck thinking about how to do composite construction the way it was done 20 years ago, which is no longer the case. there's many new types of decking systems available. Some manufactured right here in South Africa that are very innovative. You can contact me, and I can definitely share all the information I have about this, because that's what the Institute is there for, is to promote all the new technologies that are there. A lot of innovation, but even if it's imported, it's not a problem, as long as your project is done correctly. So I don't see it necessarily as absolute that you have to buy something that's local. I just mean a lot of the local stuff has become so advanced that in many cases, it's even better than the stuff that you find in places like the UK and Europe. So don't underestimate also the capacity of the industry here to innovate. It's something that is obviously close to my heart. This is the sort of a lot of what we've done. We've put a lot of energy into as the Institute over the past decade. There's a lot of research, development, innovation type work. So in regards to this composite construction, there's a lot out there. So I would say you can contact me if you're doing a project, if you're curious, if you want to see what types of methods of construction are being utilized, and I can definitely share what I know with you. But there are a number of resources out there in addition to the Red Book.
Yeah, I think just the important thing to remember is that, you know, the Red Book is a ready resource. It's a tried and trusted resource, but publications do take time to update. SAISC standards take time to update. So that is really one of the big functions of the Institute, and the professionals that are at the Institute that are connected to the industry and know what's happening within industry. It's a central hub of information. It's the living knowledge of the steel sector. So just a question that we had in the chat. I just want to see if I can find it quickly. Paul's question on fire requirements, I think you have addressed. Paul, if there's anything else that you wanted to kind of touch on in terms of fire requirements, just pop your message in the chat. And then someone's saying, I have a concern with the additional cost of ceilings and associated acoustics. I'm not sure if the offset of the CC, which I'm assuming composite construction, is enough to pay for the additional ceilings and insulation. Also, the performance of a thinner slab isn't quite the same as a heavier or thicker slab. Do you want to comment on that, Amanuel?
Yes, so there are, I think, two different topics that have been raised here, both to do with serviceability issues. One is what I've just referred to earlier as vibration. For instance, when you do any of these efficient structural systems, there may very well be, let's call it, issues of vibration that have to be considered in design, which we also take time to address in the course that I give. This is true whether it's composite construction or very high performance precast systems, or in fact, any structural system that is very efficient will have this issue and has to be addressed. And then there's a good amount of knowledge and resource available now to address these types of topics. So I would say that's a design issue that must be addressed, which is correct. To build a heavier and less efficient construction method in order to avoid designing for vibration, I don't believe is legitimate. I think it should be explored and designed correctly. The light system and the efficient system, just because of what we discussed earlier with sustainability, being green, and efficiency and reducing risk. When it comes to things like acoustics, which is a very interesting topic, that brings up an interesting question. So if you're doing, let's say, an apartment building, which is a multifamily housing, let's say, of course, we've all been inside, let's call it a building made out of precast slabs. That doesn't have ceilings, and every little dinner table moving sounds like a big fight upstairs, you know. So this is something obviously that is an issue in construction, which is the fact that acoustic requirements, well, one is we don't have minimum acoustic requirements in our building regulations, and two, even if we did have them, people are not necessarily very familiar with how to design for them. So what I would say is, when it comes to, let's say, office buildings, the traditional ceiling systems that are used in composite construction are essentially hang systems that hang on wires, essentially ceiling systems. And they work quite well from an acoustic point of view. We have good experience with them in many of these office buildings that we see all over that make use of composite construction. When it comes to apartment buildings, the question of acoustics still has to be solved. There's no question about it. But the performance of a composite floor system is, in fact, typically better than the performance of, let's say, a precast floor system. So And we're talking about, so the performance in acoustics terms, the performance is measured in decibels, which is essentially how much sound is transmitted between one floor and the next. And we've actually done these measurements with various types of floor systems. And we find it to be not as good as if you put a ceiling system in, but even without a ceiling system, it still outperforms some other competing floor type systems. So yes, there is a cost associated with ceilings if you have to perform acoustically, but then that problem is, I would say, also true for various types of other efficient floor systems. Of course, if you go to your old, pretty thick cast in place type of concrete systems, it may not be as much of an issue, but then you have these other issues to address, obviously, in terms of inefficiencies and other issues that I raised.
Can I just comment on that? I think it's...
Yes, perfect.
I don't mean to be rude. I think you're oversimplifying just a little, and it depends on the cost bracket of the building and the typology. I'm currently working on student residences where there's a lot of competing constraints, one of which is time, and obviously a composite construction is fantastic for speeding up construction, and especially on tight urban sites. But at the same time, we typically use, say, a 200 to 300 or 250 to 350 precast echo type system, which has got massive sound absorption capabilities, and you just paint the underside. It's very well finished. Whereas here you are going to have to put in acoustics, like not necessarily class A ceiling, which is standard, 6.9, let's call it a 9mm board, and hangers and insulation for acoustics, because the underside of the composite slab, as I understand it, is fairly reflective at certain frequencies. If the frequency is wider than the gap of the box rib, you're going to get reflection because it's a highly reflective surface. And acoustics are a bit of a black art, so sometimes you'd think it's going to absorb and it won't. It goes through the ceiling as a tympanum, like a drum head, hits the thing and comes back and vibrates. So that's why we tend as architects and designers to favor thicker, heavier components. They just absorb a broader range of frequencies. So on a low-end project, that becomes an issue because cost is always a problem. I think on a high-end project, it probably doesn't matter because you've already accounted for additional ceiling costs and what have you, and you're probably going with Class A. So for me, that's not an issue. For me, the issue is cost and time on very certain kinds of typologies. Maybe in more sort of industrial sort of applications, like an office in a warehouse, it doesn't really matter. But for me, in my current situation, we've engaged with a company called Voidcon. You probably have heard of them.
They're attending right now.
Hello,
okay.
Hello, Andres. Hello, Kennedy.
Yes.
Okay, are you from Voidcon? Okay. Well, they're busy doing a small portion on our site, and because of lockdown, I couldn't get to see it. And we're going to test it out. So I'm curious how that would differ from the old bond deck type systems. I don't know if it's more or less the same.
Yes, Matthew.
Yeah, those are my concerns anyway.
Yeah, yes, correct. So I was referring to acoustic performance between floors. What you're referring to is reflection, which is, of course, obviously also an issue that one has to address. And for instance, in offices, you may very well be doing this currently, these open type of ceiling systems where you don't have a full solid ceiling, but where you have obstructions to the sound that are sort of strategically placed, have been used very effectively to deal with this reflection of sound, or echo, as we'd call it. This is one method that I'm familiar with for the issue that you're raising, Matthew, is this not solid ceilings, but essentially architecturally interesting obstructions to the sound waves that don't necessarily have to be a full ceiling. So I don't know if you've explored that in your project, but that's definitely
we haven't, because on student reses, you basically have to make it idiot proof. You can't have anything exposed that you can jump up and grab or destroy.
Cool.
Because they will.
Right. Yeah. Cool. Thanks, Matthew.
Okay. Great. Thanks for that, Matthew. There is another comment from David Green, and I don't know if either Andres or Kennedy want to add anything else in there, since we have mentioned Voidcon. But while we're chatting there, just any comments on composite design with castellated or cellular beams? I'm pretty sure that the people from Cousins' ears are pricking up now. So any comments on composite design with castellated or cellular beams with regards to pitfalls and things to look out for? And then there is a second part of the comment, but let's just get to that bit first.
Yes, I think the short answer is yes. The composite construction is very amenable to the use of castellated and cellular beams. And in fact, it's quite common or commonly used, especially in things like industrial buildings and parking spaces, because you can span quite long distances. For instance, some of these projects that Spencer did a few years ago now, of course, in Cape Town, where they put up additional floors on existing buildings, were all done using castellated cellular beams. I mean, you can span 15 meters easily with composite systems for, let's say, parking areas and stuff. With these castellated, because they're deeper and it's still quite efficient. This is the one other area that is interesting in terms of composite construction, is you can actually go and put up several stories on existing buildings using these methods, because the structure is so light as compared to the heavier traditional systems. And we're talking now, in that case, what we're discussing here is the use of existing structures and foundations to utilize them even more so. And of course, you can't really get any more green than that. Instead of going and doing essentially a greenfield kind of project. And Spencer's done quite a number of those. The international terminal at OR Tambo, also, you know, when you go to the cafe, you know, where you go and eat and drink, is also, I don't know if it's castellated, but it's also composite floored. And of course, that was also done by Spencer. And what was very clever about that is they didn't have to shut down the taxiways for the planes. So they manufactured the whole thing up, sort of off-site, and literally drove in those restaurants. So if you've ever been there, I mean, these are not small structures, but they literally brought them in on rollers and stuck them. So the kinds of savings that you have for the, whatever they're called, the guys who own the airport, in terms of the closure period being very short, is incredible. So in that sense, I mean, this is what I was referring to earlier about modular construction and light construction on existing buildings. So yes, I would very much encourage the use of castellated cellular beams. When it comes to fire resistance, of course, you've added to your surface area to mass ratio, and that's typically not very good for fire, because essentially the resistance for fire is a radiation problem, has a lot to do with your surface area that's exposed to radiation. And so then you'll need more protection. So there's a balance there. The economics has to be done, again, by the engineer, not by some person sitting out there far away selling fire protection.
I think also just a comment from me just on that is obviously the castellations are great for services and you don't have to keep calculating holes through your beam. But I think the architects also don't realize that you can't just swap out a normal beam for a castellated beam without going deeper, you know, because you're not getting the same flange sizes and things like that. So there can be issues like that. I suppose that conversation needs to be had very early on in the project. Yeah.
Yep, correct. Yeah.
David, did you just want to on your second comment in there with comments regarding to sensitive floor finishes over beam line? Since we've got you on your camera, do you just want to maybe elaborate on what you meant there?
Yeah, I think, and it's something that I have my own, ideas in my head, but perhaps just for the benefit of others as well. You know, when you do these composite structures, you don't necessarily design the beam to be continuous through the column, and then your slab, of course, now it's a continuously poured slab over the top, but you're ending up with essentially a number of simple spans, but the concrete is continuous physically, and then it wants to create a hogging moment, and you suppose you can get cracking in certain areas. So some extra top mesh is probably prudent. I mean, but I suppose Amanuel can comment further.
Yeah, yes, I'm in agreement that from an aesthetic point of view, some additional reinforcing at the top in those hogging areas, especially over girders. What I mean by girder is obviously the beams that go between columns as opposed to the infill beams. Does make a lot of sense. One thing that David, you remind me of now is once you've done composite buildings for a little bit and you've got, let's say, a feel for it, one thing that you can get rid of, and this is a major benefit also in construction, is the screed. So this is very interesting from many different points of view. one is, of course, from a contractor's point of view, the amount of, people always think the screed is just nothing. It's just some 50 millimeters or 75 or 100, I don't know, that you just go and put on. And it's an easy thing to just specify. But in reality, of course, in terms of your programming and construction, it's a horrible thing. The screed is one of the most disruptive, let's call it, construction processes in construction. Because it requires its own management, it requires its own material procurement, it requires its own quality. I mean, it's a whole, let's call it, thing. So it's the screed obviously is required, I understand, on formed construction. Essentially, it's construction that's built on formwork, because it's, from what I understand, the contractors find it difficult to get a level floor, especially once the propping and everything is removed. I know of pretty large projects around Joburg here where the screed was in the range of 150 and 170 millimeters thick. Places where most of you have probably walked. Again, this is relating to quality issues. But with composite construction, it is actually possible, depending on the floor finish that one is anticipating, obviously, to remove this by designing and specifying it correctly. This takes some practice. It takes a while. It takes a lot of working very closely with the, let's call it, the steelwork erectors and the guys who do the concrete works and the decking. But it is actually possible, and in fact, it's quite standard in many countries that there's no need for screed on composite construction. So I'm glad you brought up this whole thing of floor finishes, because I just remembered now. So a very important element of composite construction, which is to eliminate one of the biggest headaches in construction, which is the screed.
Thanks for that. So Amanuel, we've got a question from Andres, just asking if you can maybe touch on partial composite designs.
Yeah, so I didn't get much into the details of this, because we're essentially just introducing many of these topics. But composite construction can be done in many different ways. The idea is to make the concrete and the steel work together, typically using these things called shear studs. Now, a clever way to do that design, of course, is to optimize. And what I mean by that is concrete is very strong in compression. We know this, right, from all of our schooling in the old days. Steel is very good in tension. What we're trying to do is to utilize these two materials in the ways in which they're good. So sometimes one may find that there's no need to make them work together in full composite action, because you may get a lot of economy from simply making them work together partially. What I mean by that is that they work independently a little bit and in composite a little bit, right? So it's a mix. These are kinds of topics we cover, of course, when we do the courses. And of course, the advantage of that is then you don't have to put in as many shear studs, right? You can put in significantly less shear studs, which helps both in your speed on site, the amount of quality control you need to do, and just overall cost. So in a way, I'm glad this question came up, because composite construction puts, let's call it, quite a bit of burden on the design, but solves a lot of the issues on construction. Now, of course, this makes a lot of sense, right? Because your design is a very small proportion of the cost of a building. So to lower the amount of design required and to add the burden on construction makes very little sense from an owner's point of view. Of course, everyone has their own little life that they live. The consultant wants to make as much as possible for doing as little as possible. The construction wants to get paid as much as possible for doing as little as possible. But if you look at it from an owner's point of view, it does make sense to spend a lot of time planning and designing, and as little time and as little resource as possible constructing. And that's what composite construction allows you to do. It is and maybe involved than when you're doing your other methods of construction. Composite action, acoustics, fire protection, all of these topics have to be addressed by the engineers and architects at the beginning, and including cost. Again, I would like to say that the cost must be addressed, especially relating to fire protection, by the engineer, not even by the architect, by the actual engineer, because the sizing of the members is directly linked with the fire protection. So if you're doing a project where the architect is specifying the fire protection, or even worse, a QS is specifying it, then it's not being done correctly. So, I mentioned this because this is what I see on projects being done in South Africa. So just thought I would point it out.
Right. Emmanuel, not to put you on the spot, but can you give people that are attending a little bit of insight into the project that you did with Stellenbosch, or the ongoing project with Stellenbosch that's specifically related to this fire-related topic?
Okay. It's a little off topic, but I'm glad you bring it up. Again, these are sort of our hobby projects, let's call them. A bit expensive, but cool hobbies. I get involved with a lot of R&D and development, product development type work. It's one of my favorite parts of the job. And we've been fortunate enough to get quite a bit of support from industry, but also from government institutions like the Department of Trade and Industry and Competition. So recently we did a project where we tried to actually see if we could build steel structures that don't need any fire protection. Right, that was sort of let's call it the overall mandate. We actually did invent such a system, which can be used in office building construction, that can do a 1 hour, essentially fire resistance without applying any fire protection. We think it's a clever method, but of course, it's not enough to just think something is clever, or to go and just try to design it on paper. When it comes to innovation, there's a great deal of requirements by the building regulations that you have to confirm that whatever you think is going on is actually true. And it's not enough to do it on paper, you actually have to go and test it. So in the process of doing this project, we've actually gone and built a whole fire lab that can do fire tests on large structures. So our structure specimen is about 100 square meters. So it's quite big, and there isn't any furnace that can do that anywhere in South Africa. There's small furnaces at CSIR, but they're typically for elements. But not only that, through the project, we also have now an expert in fire research, Richard Walls at Stellenbosch. So in a sense, what we've actually managed to do over the past 8 years is set up one of the most extensive academic research and laboratory capacities in Africa, in the continent. In fact, it's the only one of its type in the continent, to do large-scale fire type of investigations. And it's gotten quite a bit of attention internationally also, because this is sort of an emerging area of work, fire resistance, as we all know, because we hear about fires. You've heard about the fire at the library in Cape Town, this Joburg Gen I was just telling you about. In CBD, we have fires once every a while. And then, of course, you hear about the international issues like Grenfell in London. So this is actually a major sort of area of development in terms of research and also construction. So I'm very proud of the work that we've done in that area. And we have, essentially, the work is ongoing, the R&D, but we believe we have come up with a method of constructing in steel where you get a 1 hour fire protection without any need for additional fire protection on the steel. And it's a modular method of construction that has various other things associated with it. We don't have concrete in there either. So just some tidbits in there.
Just a little something I thought we'd share. We will be doing a future session on these things
and we've produced a number of master's students out of it. A PhD student is just about to finish. We have involved many students. I would say it's a highlight of, let's call it my job, right?
Nice. So just if you've got any more questions, we've got a couple of minutes left, about 7 minutes left. So any other questions can go into the chat, or if you want to put your camera on, you can do so. I'm just going to pop a few links in the chat. If you need to get hold of any publications, there's a link for the SAISC bookshop. There's a link to the Red Book, which does cover some of the topics we've been talking about today. If you're not a member of the Steel Institute, there'll also be a link there to go and have a look at what membership entails. Some of our upcoming topics, we've also got a link there where you can see what's coming up in future. If you got here by a link being forwarded to you by a friend, there's also a sign up link that you can follow, the YouTube playlist for any of the sessions that you've missed, and then also Steel Awards. We've got Steel Awards coming up in 2022, but projects will be judged in 2021. So the nomination form is in there, and then you can just find out a little bit more about that. Let me pop it in there. Emmanuel, your next session, do you know what that is? Do you need me to check? So that we can tell the people what's happening.
Yes, I think we're discussing cranes, right?
Yes,
or
so
yes,
crane gantries.
not necessarily cranes, but yes,
okay.
buildings
Okay.
that have cranes in them, which are rare these days. So
Okay, so that will be our topic coming up. Next week we've got a roofing and cladding related topic. So if that's something that interests you, be sure to join us for that. We are adding a couple of new topics onto our upcoming topics section. So just watch out for an update in that section in the coming days. There'll be something up there. Yeah, so I've mentioned as well that if you have missed any of these sessions, we do try and get the recordings up within a 24 to 48 hour time period. So if you want to just go over the recording, or there's some of the sections that you kind of want to just refresh your mind on. Emmanuel, any other questions that have come up recently, or any other projects you want to highlight that are specifically related to composite design, or anything you want to say in closing?
Just something that has come up that I saw. A lot of, with COVID and all, a lot of these office buildings, I think might be headed in the direction of being converted to residential. I've seen at least one or two large projects where this kind of conversion is going on, because people are working out of their homes, and the commercial, let's call it, building industry is not necessarily doing very well because of the COVID shutdowns. So if you are involved in such projects where you're doing renovation, of course, there's also the project CBD, right? The old buildings, the office buildings from a long time ago, which are also being converted to residential for other reasons, non-COVID related reasons. So if you are involved in such projects, composite construction is extremely, let's call it, useful, because taking in small bits of steel into existing buildings, attaching them somehow, and building floors out of them, or modifying a building is much easier than doing the traditional methods of construction in existing buildings. So I expect that this type of work is in fact an emerging market where you're doing renovations, retrofit. In fact, Denise, you might remember, we went to visit the old post office, Joburg post office, that was built in the 1880s and 1890s,
yes.
which has a floor system that looks like composite construction, but it's not.
So the project Emmanuel was referring to is that Russick Street post office. There is a video in there. It's not directly related to composite design, but you may want to go and check it out.
Well, it was Denise. Sorry.
Yes, sorry, we lost you. We lost you there.
Yes. So in that particular building, what they did was, I mean, it's an incredible building. That building. It's from the 1880s and 1890s, and in fact, there is a steel floor system in there that was put in 1890. I mean, South Africa essentially was at the forefront of the technology development regarding steel in the 19th century. So leaving that aside,
was that like that slightly barrel vaulted?
Yes. So it has is steel purlins with brick infill for the rest of the slab. I mean, very cool system. It's not composite, but it's brilliant. But what they did is they gutted out the whole building, left the facade because it's a historic heritage building. And what they're building inside is a steel structure that may or may not employ composite construction. But I was just referring to that project to say there's a lot of this type of thing emerging in the market now because of COVID, because of historic heritage protections and all that. And steel and composite construction is extremely useful in these applications. So I just thought I would point that out as a market where this fits.